Hello, hello everyone. Hello Hassana, Safal, Jamal Hadi, Majid PC. Hi everyone. Hello. Hello everyone. Hello Hassana. We'll start in a bit. Hi. Hello everyone. This is Favas from Dopa. We'll be discussing motion in a straight line today. We'll be discussing a few questions from that chapter. Hi. Amjad, Zia, Adira, Naushad, Anuja, Jasira, Ghada, Shibila, Jubi, Renato, Angel, Asin, Rahima, Yusra, Irfana. Hi, Jeevan, Agosh, and Sila. Alright, so it's 4 o'clock. We wait a little bit more, a few minutes. Hello everyone. Hello Asin, Nandakumar, Anna Binoy. Okay. Aksa Anna Binoy. Okay. Hi. Rashida, hi. Majid, hi. Rabi, Saudi, hi. Durai, Challa Durai, hi. Hello. So, hi, hello everyone. Good evening, Swati. Hello. So, there is a delay between, what I speak and what I get as a feedback from the chat. So, you and I have to cooperate with that. Hello, Mahari, Nandana, Sangeeta, Shafi, Dulya. Hi. Hello, everyone. So, hi. Let's stop with the hi and let's start the chapter. Okay, we'll discuss a few questions. These are level 3 questions. It's going to be slightly long questions, lengthy questions. So, we'll discuss a few of them. We don't have a target. We'll discuss as much as possible. Okay, I think I have around 20 questions prepared. We have around 1.5 hours time. So let's see how many questions we can solve. Okay, so you can also ask, if you have any doubts or questions. So I'm just gonna brief you with the chapter motion in a straight line. Hello everyone. Hi. There are a lot of people: Mehri, Ashna, Hussein, Hiza, Christina. All right. So let's start with the chapter. Okay. So in the chapter, we have divided the chapter into 4 sections. The first part is the definitions. The second one, in the first part in the definitions, we have hi Kirtana, hi Fatima, Mayusha. All right. Hi. Good evening, everyone. Savin, hi. So we have defined a few quantities. What is motion? What is position? How is motion defined? Motion is when an object changes its position with respect to a reference, or with respect to time, or with respect to surroundings. That is known as that is defined as motion. So position is defined with respect to some reference, frame of reference. We have x, y, z coordinate system, or x, y plane, or north, south, east, west directions. Those kind of things, coordinate systems. All right. So those are basically reference points, reference frames. Hi everyone. Then we have defined a few other quantities like displacement, distance. Displacement is a vector quantity which has a sense of direction. Distance has no sense of direction. It's actual path covered. It's actual distance covered. It's a path length. The distance is the path length. Then we have defined velocity and speed. Velocity is a vector quantity again. It's the rate of displacement. It's a displacement covered in unit time. Hi Usha, Blake Olive, Riaz, Shadia, Sana, hi. So then we have defined acceleration. So we'll be looking at we'll be using these quantities extensively. Then we have moved on to graphs. We have 3 types of graph: position time graph, velocity time graph, and acceleration time graph. In each of these cases, we have drawn graphs with when the object is at rest, Hi Hritika. The object is at rest and the object is moving with the uniform velocity and the object is moving with the uniform acceleration. So we have drawn 9 different graphs. Then we also said that the slope of position time graph, Aditya Nish, hi, hello. The slope of position time graph is the velocity and the slope of velocity time graph is the acceleration. In the reverse order, the area of velocity time graph is the displacement and the area of acceleration time graph is the change in velocity. Hi Shamili, hi. Then we moved on to equations of motion. So we will be using these equations extensively, equations of motion. V equal to u plus at, S equal to ut plus half at square, and v square equal to u square plus 2as. These are the 3 equations of motions. All right. Hi Sujit Kumar. Hi. Hi Nia. All right. So then we have moved on to discuss 2 different one typical example of one-dimensional motion, that is the motion under gravity. Motion under gravity. That is free fall, either free fall or vertically throwing upward. Okay, so we have formulated different ratios in case of free fall. Final velocity, the equation. Hello, final velocity has the equation v is equal to root of 2gh. Hello Minsha, Nishad. Are those 3 equations important? Yeah, they are really important. All right. So then we move on to relative motion. Relative motion. The simple idea in relative motion is that velocity of object 1 with respect to object 2 is v1 minus v2. Okay. These are actually vector quantities. So if they are in the opposite direction, you have to take negative. And those velocities will become sum of velocities. All right. So hello everyone. Hello Hridya. So yes, let's move on to the questions. Okay. So let me read out the question for you first. You can try it yourself. A car travels first 1/3 of the distance AB at 30 km per hour. The next 1/3 of the distance at 40 km per hour, the last 1/3 of the distance at 24 km per hour. Its average speed in km per hour for the whole journey is. So yes, you can try that. We have a formula, we have derived a formula for finding the average velocity or average speed. V average is equal to 2v1 v2 divided by v1 plus v2. When half of the displacement or distance is covered with some velocity v1 and the next half of the displacement is covered with velocity v2. Now in this question, the displacement, the total distance traveled is divided into 3 parts, 1/3, 1/3 and 1/3, not 2 halves. Okay, there are 3 parts. So in that case, we cannot use this formula. We will have to use the original formula for average velocity or average speed. That is the total distance or total displacement by total time. Total displacement divided by total time. Total time. Hello everyone. What about relative velocity? Yes, relative velocity, relative motion, that's what v12 is equal to v1 minus v2. That's what relative velocity is. Velocity of object 1 with respect to object 2. So we have discussed all those things in the sessions. All right. So now let's work out a few questions. So this question, a car travels first 1/3 of the distance AB at 30 km per hour. So we have 3 different velocities. V1, which is 30 km per hour. V2, the next one is 40 km per hour. And the third one, V3, is 24 km per hour. 24 km per hour. So we want to find out the average speed. So try it yourself. The equation is total distance traveled by the object divided by the total time taken. That's what average velocity or average speed is. If it is total displacement by total time, that's what the average velocity. If it is total distance by total time, that's average speed. So any of you got an answer? So you can try it yourself. we have the distance. Let's divide the distance to this is the object is moving from A to B. We have divided that distance into 3 equal parts. Let's say the total distance is S by 3, S by 3, S by 3. All right. Mumtaz is saying the average is 30. Let's see. I'm not sure actually. Okay. So let's find out whether the average is 30 or something else. Okay. So what is the total distance traveled? Total distance traveled is S. What is the total time taken? So first 1/3, the velocity is actually 30 km per hour. 30 km per hour. The second 1/3, the average is 40 km per hour. And last 1/3, the velocity is 24 km per hour. All right. Someone else is also saying the average is 30. Maybe, I'm not sure. Let's work out. Okay, I don't know the answer actually. So let's work out. So the total time taken, time is equal to displacement by velocity. Time taken to cover the first 1/3, we can take that is S by 3 divided by 30, plus the next 1/3 S by 3 divided by 40, plus the next 1/3, yeah, many of you are saying the answer is 30, maybe. And the last 1/3 is S by 3 divided by 24. All right. So the average speed is equal to total distance S divided by S by 3 into 30 plus S by 3 into 40, 3 into 40 plus S by 3 into 24. So you can cancel all the S's, take the S outside and cancel all of them. Now let's see. 1 divided by 1 by 3 can be taken out, or 1 by 3 can be taken out. Then it's going to be 1 by 30. Let's work out over here. 1 by 30 plus 1 by 40 plus 1 by 24. So this 3 is going to be on the top, 3 divided by. In that also 30, 40 and 24, the common thing that we can take common, can only take 2 as common. So 1 by 2 into 1 by 15 plus 1 by 20 plus 1 by 12. All right. What is going to be the LCM? So those 2 also comes onto the top. It's going to be 6 over here. 6 divided by, in the denominator 15, 20 and 12, the LCM is going to be 60. So let's multiply by 60 and divide by 60. So this is 60 into 1 by 15 plus 60 into 1 by 20 plus 60 into 1 by 12, whole divided by 60, or multiply on the top by 60. So this is 6 into 60, that is 360 divided by 60 and 15 cancels and it's 4, plus 60 and 20 cancel, it's 3, plus 60 and 12 cancels and it's 5. So this is 360 divided by 4 plus 3 plus 5, it's 12. So this is actually 30. Indeed, the right answer is 30. Okay. To find the answer, it takes too much time. Of course, it's going to take too much time. And once you practice, you will get faster at it. Okay. You will attain the speed only by practice. Okay. So the answer is 30 km per hour. Yes, of course, is that possible to find the answer while we are on the exam hall? Of course, you can find the answer. Not every question has to be done in 1 minute. Okay. So for NEET exam, you guys, all of you are preparing for NEET exam. So in NEET exam, we have 180 questions and 180 minutes, and the time given is 1 minute for each question. But it does not mean that every question has to be done in 1 minute. There will be questions which can be done even in 10 seconds. Just read the question, you know the answer. So it's going to take just 10 seconds for some of the questions, and for some other questions it may take 2 or 3 minutes. Okay. So what you do is, first read the question paper, read out one by one. If you know the answer, and attend that question. Okay, if you know the answer, attend it or bubble it. And if you don't know the answer, leave that question. And if you know that's going to take a lot more time, if you know that that question, you know how to work that out, and you are sure that it's going to take much more time than 1 minute, then leave that question aside for that time. Okay, then once you complete one round of that paper, come back. You will have time. That's how you attend an exam. So you will have time, and you can come back and work out the problems that you know how to solve, but going to take more time. Now, in the second round, you will be working out problems that is taking more time. And in the third round, you may be working out some of the problems that you thought you don't know. Let's say when I read a question, I think I don't remember this type of questions. I don't know how to solve that. We keep that aside. Okay. I read a question. I find it. I know how to solve this, but it's going to take more time. So I keep that question also aside. Then I read another question. I know the answer. I attend it. Or I know it's going to take a few seconds, just 2 or 3 steps. I solve it. I mark the answer. Okay. So in the first round, I'll be working out the problems that I already know is going to take much less time. For NEET exam, it's always +4 and -1. For the positive, for the right answers, it's going to be 4 mark. And for wrong answers, it's going to be -1 mark. So in the first round, we'll be attending questions that are very, very easy, and it's going to, you can solve it in a few seconds or by under 40-45 seconds. And you'll be keeping 2 types of questions aside. One, that you know how to solve it, and the second one, that you don't know how to solve it. So once you complete the question paper 1 round, okay, means you have attended all the easy questions. You come back and work out the questions that you know how to solve, but going to take more time. All right. In the third round, if you have time, you can, try to crack some of the problems that you don't think you know. Okay, try to remember a few equations and try to solve some of the questions that you thought that you don't know. That's how you solve. Okay, not every questions can be solved under 1 minute, and not every question is going to take 1 minute to solve. Okay, there will be questions which requires very much less time. All right, so the answer is 30 km/h. So in the question itself, it's asked how much time, or in the unit is given, it's km/h. So the right answer here is 30 seconds. Okay. Moving on to the next one. I hope if you have any doubts, you can ask me. So we have a formula if the velocity is, if the total displacement is divided into 2 halves. We have the formula if the 2 displacements, so total displacement is divided into 2 halves, then the average velocity is 2v1 v2. Most of the questions are from +1 syllabus. Is that true? No. For the last NEET exam, that means today is the NEET 2020 result. For that NEET exam, out of 45 questions for the physics, I guess around 17 or 18 of them were from +1, and the remaining 27 of them were from +2. Okay, usually that's not the case. Usually it's around 50-50. 50% of them are from +1 and 50% of them are +2, but slightly, it can be 55-45%. That can also happen. Okay, but in the previous year, in this year 2020, the percentage of questions that came from +2 was much more actually. Okay, so the right answer here is 30 km/h. So the significance of this question is that we have a formula. If the total distance or displacement is divided into 2 halves, then the average velocity is 2v1 v2 by v1 plus v2. But if we don't have, if this total distance or displacement is divided into 3 parts, 1/3, 1/3 and 1/3, we go back to our original formula. The average velocity or average speed is equal to total distance or total displacement divided by total time. So you guys have a lot of questions. Okay, Let me try to answer a few of them. Is the NCERT textbook is the best guide? Yes, I guess. Okay. So first you learn, you understand NCERT fully, then you can try to get more materials to work out more lot more problems. If you need practice, you have to if you need speed and accuracy, you will have to work out or practice more problems. For that you can access other materials. For the syllabus only, NCERT NCERT is good enough I guess in all the three subjects: biology, chemistry and physics. Okay. Physics, you will need more and more materials, more and more questions for you. That's the problem. Okay. So let's move on to the next one. You can read the question and try it yourself. A ball is thrown vertically upwards from the ground. It crosses a point at the height of 25 meters twice at an interval of 4 seconds. The ball was thrown with the velocity of. The ball was thrown with the velocity of. So it's actually a question from vertically throwing upward. Okay. Vertically throwing upward. Motion under gravity. So try it yourself. Ball is thrown vertically upwards from ground and it goes up and comes back. It crosses a point at the height of 25 meters twice at an interval of 4 seconds. Good. The answer is 30 meters per second. Good. So it goes up and comes back. So what we need to find out, the ball was thrown with the velocity of, we need to find out the initial velocity of the ball. Okay. The given information is that it crosses a particular level. The level in means over here it's at 25 meters. 2 times while going up and while coming down. So that same height will be attained 2 times while going up and while coming down. So at an interval of 4 seconds. So if you consider only this part, the total time taken is equal to 4 seconds. Consider that part as a vertically throwing upward. Okay. So for that the total time of flight is given as 4 seconds. Right. It crosses the 25 meter mark at an interval of 4 seconds. It goes up and comes down. Okay. So this velocity, let's say if it is v, then the time of flight is equal to 2v by g, which is given as 4 seconds. Okay, which is given as 4 seconds. So from that, v is equal to 4g by 2, or this is going to be 2g, or this is 20 meters per second. All right. It's 20 meters per second. While going up, this velocity over here is 20 meters per second. Okay. Now, we know that if this object is thrown up with velocity u, it is also coming down with velocity u, right? So consider the downward motion. Consider the downward motion. If you consider the downward motion, we know that the velocity over here, if it is 20 meters per second up at 25 meters over here, and this is also going to be 20 meters per second over there. 20 meters per second. So now let's consider only this part while coming down, only this part. All right. This height is 25 meters. The initial velocity is 20 meters per second. While coming down, we have g acceleration due to gravity, which is vertically downwards, 10 meters per second square. So we have the initial velocity, which is 20 meters per second, or let's consider this as, this is actually the initial velocity. This point is considered as the initial, and this is considered as the final. All right. So the initial velocity is 20 meter per second. The final velocity, that's what u is, what we need to find out. Acceleration is 10 meter per second square, and the displacement is 25 meter. All right, 25 meter. So v square is equal to u square plus 2as. The final velocity u square is equal to initial velocity, it's 20 square plus 2 into acceleration is 10 plus, acceleration is 10 into the displacement is 25. So this is going to be 400 plus 20 into 25. 20 into 25. So that's going to be 20 into 25 is going to be 500. So 400 plus 500, that is 900. That's what u square is. That means u is equal to square root of 900, which is 30 meter per second. All right. So there are a lot of different ways to solve this. The right answer over here is 30 meter per second. Okay. So again, the same thing can be done. We know the ratios, right? If it is 20 meter per second, it's going to take 2 seconds. 2 seconds to reach on the top. So here we have 1 second, and here we have 1 second. This is 5 meter. This is 5 meter, and this is 15 meter. Okay, for each 1 second, it's going to be 5, 15, 25, right? So this is actually 25. That means, what does that mean? That means over here, the velocity is actually 0 meter per second. Over here, it's 10 meter per second. We have seen this, and over here, it's 20 meter per second. Over here, it has to be 30 meter per second. So if you can think like that, that is also, that's the easiest way. So it crosses the same point at 25 meter height at an interval of 4 seconds. That means 2 up and 2 down. Okay. And you have to come another 25 meter down. Okay. So 2 seconds means in the first second it's 5 meter, in the second it's 15 meter, in the third it is 25 meters. So it has, while coming down it takes 3 seconds, while going up also it takes 3 seconds. So if you can think like that, it's really easy. The final answer is 30 meter per second. Okay. Some of the questions or most of the questions can be done without using equations from free fall. If a question is from free fall, please explain that. Okay, once again, let's see. Let me try to explain that once again in that way. We don't know the initial velocity. We know it crosses the 25 meter mark at some time, and while coming back also it crosses this 25 meter mark. Okay, this is 25 meter. Okay, so the total time from here to here means this motion is actually 4 seconds. That means it's 2 seconds up and 2 seconds down. So this can be further divided into 1 second and 1 second. And we know this ratio, right? This is going to be 5 meter and this is 15 meter. The ratio is 1:3:5, etc. Okay. In vertical motion, u and final velocity is always equal. Yes, at the same level, it must have the same velocity. Okay, we have found out that the velocity over here, this velocity, if you projected with some velocity, it's going to come back the same velocity. Okay, if you are in +1 and work energy power, the chapter work energy power, if that completed, then you will know the total energy has to be conserved. Total mechanical energy has to be conserved in a free fall or in a vertically throwing upward also. So if you give a kinetic energy at the bottom, goes up and reaches the maximum height, it completely gets converted to potential energy and comes down, get again converted back to kinetic energy. So the initial kinetic energy and the final kinetic energy has to be the same. So that means initial and final velocities at the same level. Okay, initial and final means the initial and final are at the same level, then the velocities are The speeds are going to be the same. Velocity is not actually the same, because initially it was upwards, finally it's downwards. Velocity is a vector quantity. Velocities are not actually the same, but the speeds, the magnitude of velocity are going to be the same. All right. So what was I saying? This can be further divided into, intervals of 1 second. So in 1 second, we know it covers 5 meter while coming down. This is going to be 5 meter, and this is going to be 15 meter. And how much else is remaining? That is 25 meter, right? So 25 meter is actually the distance covered in the third second. 5, 15, 25. So actually the total time of flight is actually 6 seconds. Or time of ascent is equal to 3, and time of descent is also equal to 3. Okay, time of ascent and time of descent are equal. So it's going to be 3 and 3. So if you look at that, initially velocity over here, at the highest point the velocity is 0. After 1 second, since we have acceleration due to gravity, g is equal to 10 meter per second square. After 1 second, the velocity is going to be 10 meter per second. After 2 seconds, the velocity is going to be 20 meter per second. After 3 seconds, the velocity is going to be 30 meter per second. That's what we said. This is 30. This is also 30. Over here, it's going to be 20. While coming down, also it's 20. Over here, it's going to be 10 meter per second. While coming down, also the velocity is 10 meter per second. Okay. So if you can think like that, if you are, familiar with these kind of questions, then it's very easy. You don't even have to use the formulas. Okay. I hope that's clear. If you have any doubt, you can ask. So, in this explanation, I have used, 1 or 2 equations. But if you can think like this, that's what I'm saying. Most of the questions from free fall and vertically throwing upward can be done without using formulas or equations. Okay. So let's see. Moving on to the next one. Velocity time graph of the 2 cars starting at the same point are shown. Velocity time graph of 2 cars starting at the same point is shown. Find the time after which the 2 cars will meet again. Let's see. This is the velocity time graph. Velocity time graph of the 2 cars starting at the same point is shown. Find the time after which the 2 cars will meet again. So both the cars are actually starting from the same point. One of the car A is moving with a constant acceleration. Okay. Car A is moving with a constant velocity, and car B is actually starting with a constant acceleration, because you look at that, it's a velocity time graph. For car B, it's a velocity time graph with a constant slope. It's accelerating. The slope of velocity time graph is the acceleration. It's accelerating. All right. So, but starting with a 0 velocity. Okay. So, do you understand the question now? Find the time after which both the cars meet again. So there is some information missing, I think. I think there is an information missing over here. Let me try and value. How did you solve that question without that information? Anuja, Gilbert, how did you solve that question without, the car A is moving with a constant velocity and car B is moving with a constant acceleration? Question, I'll explain. So there is a small issue with the question. That's the problem. Let me warn you that we may not get a right answer. I mean, we may not get an option which is in the given options. Okay. Let's consider this time. Look at the graph. I have made a modification. Yes, I can. What do you want me to tell? Yes, I can speak in Malayalam. If you want, if you have any specific queries, you can ask. I can speak in Malayalam. So let's think about it. Two cars are starting from a racetrack. Two cars. We have two cars. Car A is going to move with a constant velocity 10 meters per second. And car B, the initial velocity, car B is also moving forward. Car B is also moving forward. The initial velocity is 0. Look at the figure. Okay. Car A is going to have a constant velocity and car B is going to move with initial velocity 0, but it has an acceleration. It has an acceleration. How much is that acceleration? You can see from the figure. The slope or tan theta slope of car B is the acceleration. So slope of velocity time graph is the acceleration. So what is a slope tan theta? It's the opposite side by adjacent side. So this is going to be 10 meter per second. So opposite side is 10 meter per second divided by the adjacent side is 10 seconds. So 10 gets cancelled and this is going to be 1 meter per second square. So that means the car A, let me explain the question once again. Car A is moving forward with a constant velocity of 10 meter per second and car B is starting from the position. Okay. Car B is starting from the position, but it has a constant acceleration. Its velocity is going to increase. The initial velocity is 0. So those two cars are actually starting from the same point, but the car that is moving with a constant velocity will be, covering a lot of displacement at the beginning. Car B is accelerating, the speed is increasing gradually, and at a later time again these two cars will attain, the car having a acceleration, car B which has an acceleration, it will overtake the car A at a later time. So that's what the question is. Again, velocity time graph of the two cars starting at the same point is shown. Find the time after which the two cars will meet again. Means they started from the same point, but first car is moving with a constant velocity. It's gonna cover a lot of displacement in the beginning, but the car B is accelerating. Speed is increasing and increasing and increasing. All right. So at a later time, it's going to overtake it. All right. So that's the question. So at what time those two cars will be at the same, at the same position again? So when will the car, at later time, I can draw it like this. Since the car A is moving with since car A is moving with a constant velocity, car A might be over here, but still car B will be over here. Its velocity is increasing, but at a later time, the car B is going to overtake car A again because its velocity is continuously increasing. So that's what we need to find out. Okay. So by that time, the total displacement covered by both the cars are the same. The total displacement covered by both the cars are the same. Okay, so let's see. The displacement of car A, displacement of A can be taken as, let's take it as SA. Let's take it as displacement of A is basically velocity into time. What is the velocity of A? It's 10 meter per second into time. We don't know time. So what we need to find out is the time at which these two cars are at the same position again. Okay, so time is the quantity that we need to find out. All right. What is the displacement of B? Let's take it as SB. The initial velocity is 0. So it's going to be 0 into t plus half at square, because the second car B, has an acceleration, so the displacement is s equal to ut plus half at square. These two displacement SA and SB are equal. Okay, that's what that means. You know, the time at which both the cars are at the same position again. So the displacement covered by A, is this much, and displacement covered by B is this much. Both of the displacement are equal. Initially, car A is in the front, but at some other time, car B is going to overtake car A. All right. So these two displacements are equal. So SA is equal to SB, and 10 into t is equal to, this is 0, half. We have found out the acceleration as 1 meter per second square. 1 into t square. Okay, so if I take the 2 onto the left side, it's going to be 20t is equal to t square. If I cancel 1t on both sides, if I cancel 1t on both sides, I have t is equal to 20 seconds. Okay, so this is according to this assumption. I have given that the time at which their velocities are equal is 10 seconds, but they will the car B will overtake car A only at a later time, that is 20 seconds. Okay, so I hope that the question is clear, the solution is clear. Correct. Let's say, let me give you, a real life example. A car, a bus is stationary at a bus stop. Okay, a limited stop or a KSRTC, long distance bus is at rest at a bus stops, and a bike or a small car, it actually overtakes the bus. Okay, at that instant when the car just goes past the bus also starts. But we know that bus drivers, they accelerate very fast. So at that beginning, the bike may overtake the bus and move in the front, but after a few seconds, the bus will accelerate and overtake the bike again. Right? That's what happens. Do you get that? Initially, the bus is stationary at a stop. A cyclist or a bike rider overtakes the bus, but the bus starts with an acceleration. The velocity increases and bus overtakes the bike or a car again. Okay, because the bus has an acceleration, it has an increasing velocity. The velocity is continuously increasing. The speed goes on increasing. The other one, the car A, has a constant velocity. It's moving with a uniform speed or uniform velocity. All right. So I hope that's clear. Okay. Let's move on to the next question. You can read out that problem. It's a lengthy one. It's going to take, much more time. As I said, these are not 1 minute questions. Okay, these are higher level questions. Okay, so two cars A and B are traveling towards each other on a single lane road at 24 meter per second and 21 meter per second respectively. They notice each other when 180 meters apart and apply brakes simultaneously. Okay, they just succeed in avoiding collision, both stopping simultaneously at the same position. Assuming a constant retardation for each car, the distance traveled by the car A while slowing down is. All right. So this can be done as as a relatively, or using relative motion, or can be done without any of relative motion. So I hope the question is clear. We have a single line track, two cars, A moving with a speed of 24 meters per second, car B moving in the opposite direction with a speed of 21 meters per second. Okay. Then they notice each other. I see the other car is coming from my opposite direction when we have a 180 meter distance between them. The separation between them is 180 meter. Okay. That's when they see each other. The other car is going coming in the same line as I am moving, okay, in the opposite direction. Okay, so they just apply brakes simultaneously. They both apply brakes. Apply brakes means both of them has a retardation A. This one also has a retardation. These retardations may not be the same. Okay, these retardations, braking, may not have the same effect. All right. So let's consider as A1 and A2. They just succeed in avoiding collision. They just succeed means those two cars which were 180 meters apart apply the brakes and comes just enough to avoid, they stops just enough to avoid collision. Okay, both stopping simultaneously. So it's not like this. The first car stops, it's not like this. First car stops first and the second car stops second. No, that's not the way. Both of them comes and stops at the same position at the same time. Okay, that's just barely enough. I'll explain that question in Malayalam once I explain it in English first. Okay. Both stopping simultaneously at the same position. Assuming constant retardation for each car, the distance traveled by car A while slowing down is. So this is how the question goes. Let me translate that to Malayalam. Two cars, two different speeds, 24 meters per second and 21 meters per second, they are coming towards each other. They are okay. അങ്ങനെ അടുത്തോണ്ട് വന്നിരിക്കുമ്പോൾ അതിൽ 180 മീറ്റർ ഡിസ്റ്റൻസിൽ ഇരിക്കുന്ന സമയത്ത് അവർ പരസ്പരം കാണുന്നു ആൻഡ് apply the brake immediately. അപ്പോൾ തന്നെ ബ്രേക്ക് അപ്ലൈ ചെയ്യുന്നു. ആ ബ്രേക്ക് കൊടുക്കുന്ന റിട്ടാർഡേഷൻ കോൺസ്റ്റൻ്റ് ആണ് എന്ന് നമ്മളോട് പറഞ്ഞിട്ടുണ്ട്. ഓക്കെ, കോൺസ്റ്റൻ്റ് റിട്ടാർഡേഷൻ ആണ് കൊടുക്കുന്നത്. ആ കോൺസ്റ്റൻ്റ് റിട്ടാർഡേഷൻ കൊടുത്തു കഴിഞ്ഞാൽ അവിടെ സംഭവിക്കുന്നത് രണ്ട് കാറും വന്നിട്ട് ജസ്റ്റ് തൊട്ടടുത്ത് തട്ടിയില്ല എന്നുള്ള നിലയ്ക്ക് വന്ന് സ്റ്റോപ്പ് ആവും. രണ്ടും ഒരേ സമയം കൊണ്ട് സ്റ്റോപ്പ് ആവും. രണ്ടുപേരും സ്റ്റോപ്പ് ആവാൻ എടുക്കുന്ന ടൈം സെയിം ആണ്. രണ്ടുപേരും സ്റ്റോപ്പ് ആവുന്നതും ഒരേ സ്ഥലത്താണ്. പക്ഷേ രണ്ടുപേരും ട്രാവൽ ചെയ്ത ഡിസ്റ്റൻസ് സെയിം ആവണമെന്നില്ല. കാരണം രണ്ടുപേരുടെയും ഇനീഷ്യൽ വെലോസിറ്റീസ് ഡിഫറൻ്റ് ആയിരുന്നു. ഓക്കെ, ഓൾ റൈറ്റ്. സോ ദാറ്റ്സ് ഹൗ ദ ക്വസ്റ്റ്യൻ ഗോസ്. സോ ലെറ്റ്സ് സോൾവ് ഇറ്റ്. Let's say both the cars reach over here. This is their initial time t equal to 0. And at time t, both the cars are just, avoiding collision over here. Like this. They are just over there. Both of them are stopped. Their velocities are 0. Both of them stop simultaneously. The time taken by each of the cars to stop is the same. All right. So what we need to find out is that assuming constant retardation for each car, the distance traveled by car A while slowing down. So what we need is this distance. Let's name that displacement of A, and this is going to be displacement of B. Okay. So what we need to find out is the displacement of car A while slowing down. So let's find out let's work out, let's have some of the equations. So what is SA plus SB? Okay, I can explain the questions in Malayalam, if you ask me, if you it's required. Okay, so what is SA plus SB? Answer fast. SA plus SB. SA plus SB going to be 180 meter. SA plus SB is going to be 180 meter. That was the separation between those two cars. Now they are just close enough. So the distance between SA plus SB is 180 meter. Then look at the first car, car A. For car A, the initial velocity is 24 meter per second. 24 meter per second. And the final velocity is 0. Final velocity is 0. Good. A lot of you are answering it as 180 meter now. There is a delay. Okay. So that's fine. Good. So it's 180 meter. And the time taken, we don't know the time. Okay. That time is also an unknown. So what is A1? What is A1? A1 is the acceleration, which is going to be 24 minus 0 by t. 24 minus 0 by t. Okay. That means A1 is equal to 24 by t. That's what the retardation for car A. And similarly for B, initial velocity is 21 meter per second and the final velocity is 0. The time taken is the same and acceleration is A2. Okay. So what is A2 is going to be? It's 21 minus 0 by t, or this is 21 by t. Okay. Now, we know the equation for stopping distance. What's the equation for stopping distance? Stopping distance is, the equation is u square by 2a. The initial velocity square divided by 2 times the acceleration. So using that formula, what is SA? SA is going to be 24 squares. SA is the stopping distance of A and SB is the stopping distance of B. So SA is going to be 24 square divided by 2A1 and SB is going to be 21 square divided by 2A2. Okay. U square by 2A. Good. Anuja Gilbert. So the stopping distance is u square by 2a. I'm going to apply, I have applied that formula for stopping distance of A and B. Now we know that SA plus SB is equal to 180 meter. So let's substitute that over here. So 24 square divided by 2. What is A1? A1 is 24 by t, right? Plus 21 square divided by 2A2. What is A2? A2 is 21 by t is equal to 180. So I'm using this formula over here. Okay. So let's cancel a few of those. 24 gets cancelled and 21 gets cancelled. So this is going to be 24t it's 24t by 2 plus 21t by 2 is equal to 180. Okay. So 24, since there is a 21 by 2, I'm going to keep that as it is. Okay. Is there only one equation for stopping distance? Yes, I guess. So, for stopping distance with initial velocity and acceleration, the stopping distance is u square by 2a. Okay. So anyway, this is going to be 45t by 2 is equal to 180. I can cancel the 45 and 180. This is 4. That means t is equal to 8. Okay. So then what we need is SA, right? So SA is equal to Fasha Sharif. I guess the right answer, 96 is the right answer. Good. So this is 24 square divided by 2 into A. What is A1? A1 was 24 by T. Yes, 8 seconds is the time. That's not the question. They are not asking us to find out the time. Okay, 8 seconds is the time. So the 24 gets cancelled again. So this is going to be 24t by 2 or 12t. 12t, that is 12 into 8. Yes, it is. It's 96 meters. Okay. So I hope all of you has the right answer. They are asking us to find out SA, not the time. So the right answer is 96 meters. So here we have not used, relative motion. We can try that also. Okay. We can try the same question using relative motion. Okay. So how do we work out this problem with relative motion? So let's move on to that. I hope everything is clear till now. We have the answer. We have the answer, which is the displacement of car A while slowing down is 96 meters. So that's the right answer. Let's move on to work out the same problem using the idea of relative motion. Okay. So the car was over here, A, and this is car B. These two cars are moving with velocities 24 meter per second and 21 meter per second in the opposite directions. Okay. The separation between them is 180 meter. 180 meter. Okay. So okay. So finally, those two cars reach over here at time t. Initially, the time is equal to 0. At time t equal to 0, those two cars are at 180 meter apart. Okay. So these two cars has retardation, let's say A1, and here this one has retardation A2. Okay. Now, at time t equal to 0, what is the position of car 2 with respect to car B with respect to car A? At t equal to 0 means initially when everything starts happening. What is the position of car B with respect to car A? Car B with respect to car A. Car B, that's what, a relative motion means. With respect to A, assuming A is at 0. A is at 0. Assuming A has the frame of reference on top of it. Okay. So assume that car A has the, car A has the reference frame along with it. So what is the position of car B with respect to car A? Car B is at a distance of 180 meter with respect to A. Alright. So the initial position of car B with respect to A is actually initial position of car B with respect to A is 180 meters. What is the velocity of car B? Sorry, initial velocity of car B with respect to car A. Initial velocity of car B with respect to car A. We have to consider this direction as negative and the rightwards as positive. Okay, so car B is actually 180 meter plus 180 meter away from car A, and car B is moving with the speed of 21 meter per second, and car A is also moving with the speed of 24 meter per second. So initial velocity is actually UB minus UA, but those two are vector quantities. Okay, so the velocity of car B is minus 21. Follow that, minus 21, and the initial velocity of car A is 24 minus, but car A is moving with the positive velocity. So this is equal to, minus 45 meter per second. Minus 45 meter per second. All right. Okay. Now, what is the relative acceleration of car B with respect to car A? That is going to be AB minus AA, or A2 minus A1. But here A2 is positive and A1 is negative. A2 is positive and A1 is negative. Why? Because A2 is towards the right and A1 is towards the left. Both of them are actually brakes, retardation for each of the cars. All right. So this is A2 minus A1, or you can say it's A2 plus A1. Okay. So we have the initial velocity and we have the acceleration as ABA, or A2 plus A1. So now between those two cars, what is the stopping distance? With respect to car A, finally, relative position of B with respect to A, finally those two cars are just enough to collide. What is the relative position of B with respect to A? Those two cars are just over there. Those two cars are just colliding, right? So we have the reference, on top of A. Reference on top of A. So what is the final position of B with respect to A? That is the same thing. So relative position of B with respect to A finally is actually 0. So it was at 180 meters. Now it is at 0 meter apart. Initially they were 180 meter apart. Finally they are at 0 meter apart. They are at the same position. All right. So what is the displacement? Relative displacement of B with respect to A. Finally it is at 0 meter. Initially they were at 180 meters. So this is minus 180 meters. Okay. So what are the things that we have? The displacement of B with respect to A is minus 180 meters. The initial velocity of B with respect to A is minus 45 meters. The acceleration of B with respect to A is, what was that acceleration? It was A2 plus A1. Okay, and we don't know the time. Okay. What is the final velocity of B with respect to A? That's one thing that is missing. Final velocity of B with respect to A. Finally, both of them are at rest. Finally, both of them are at rest. Okay. Finally, both of them are at rest. So the relative velocity is 0. So we have the displacement, we have the initial velocity, and we have the final velocity. So we can find out the acceleration. All right. if you use v square is equal to u square plus 2as. We can use the same formula for relative also. VBA whole square is equal to UBA whole square plus 2ABA ABA into SBA. Okay. So this is 0 square is equal to minus 45 square plus 2 into acceleration. We don't know what's acceleration, ABA, into the displacement is minus 180. This is 45 minus 180 meters. So from here, this is going to be 2 acceleration of B with respect to A into 180 is equal to 45 into 45. So you can cancel one of the 45s. That is going to be over here it's 4. So acceleration of B with respect to A is 45 divided by 8. Okay. So this is the acceleration of B with respect to A. Now using the same conditions we can find out the time. Okay, we can find out the time. So we have the acceleration, initial velocity, acceleration and displacement. We have initial velocity, acceleration and displacement. What is the acceleration? Acceleration is 45 by 8. So using that we can find out time. Use the formula is equal to ut plus half at square. So displacement is minus 180 meters. Initial velocity is minus 45 into time plus half. Acceleration is 45 by 8 into time square. Okay. So you can cancel 45 in each of the terms. This is 4. So minus 4 is equal to minus t plus t square by 16. Sorry, t square by 16. Okay. So multiply everything with 16. So this is minus 64 minus 16t plus t square, or t square minus 16t plus 64 is equal to 0, or this is t minus 8 the whole square is equal to 0, or t is equal to 8. So the same thing, we are coming back to the same thing. The time taken by the two cars to stop is 8 seconds. Okay. So now we have the time. So you can see that this method is taking much more time than the first method. Okay. So there are a lot of methods to solve the same question. And how do you know? I mean, we want to solve every question using the method which takes the least amount of time. How do you know which one is the method which takes the least amount of time? How can you understand the method that is going to take the least amount of time? So we have the time now. So the displacement is initial velocity of A for car A. Initial velocity is 24 meter per second, final velocity is 0, t is 8 seconds, and we need the displacement. Here we are not using relative motion, so v square equal to u square plus 2as. The velocity is actually minus 24. No. Sorry, we have initial velocity, final velocity and time. We have initial velocity, final velocity and time. Let's find out the acceleration. Acceleration is equal to 24 by 8. 24 minus 0 by 8, which is 3 meter per second square. So s is equal to ut plus half at square. So this acceleration is going to be negative because this is 0 minus 24. Okay. So this is 24 into 8 minus half into 3 into 8 square. So 24 into 8 is 192 minus 3 by 2 into 64, this is 32. So 192 minus 96, which is equal to 96. So we get the same answer. We get the same answer, but it's going to take much more time than the first case. Okay. So I have asked you a question. What is your opinion? How do you, I mean, we know that there are a lot of methods to solve problems. For a single problem can be solved with the different methods, 2 or 3 different methods. Okay. So how we always want to do every question with with much less time. Okay, with as much less time as possible. We don't want to take much more time. So how do we know which method is the fastest method when reading the question? How do we know which method is the fastest one while reading the question in the exam hall? So that's a question for you. Please answer your opinion. This is a different method. Okay, the same problem can be done using relative motion also. I thought this method is going to be simple, I mean taking lesser time, but I was wrong. Okay, I thought this is going to take much lesser time, but this was much more lengthy than I expected. So how do you know which method is the simple one? Which method must be used to solve a problem in the exam hall? While reading the question, you are thinking about 2 methods. Or while reading the problem, how do we know which method is will get you the answer fastest? So give me your opinions. Okay. So we are moving on to the next question. Moving on to the next question, you can type you can type your opinions about how to know which method is going to help you solve a problem fastest. How to find out the fastest method, easy method. Okay. So moving on to the next question, you can type your answers in the chat. The velocity time graph of a body traveling along a straight line is given below. Velocity time graph of a body traveling along a straight line is given below. The distance traveled by, I have the right answer in the first try itself, Aisha. Yes, the right answer is you never know. You never know the method that you are trying is the fastest or the slowest. You will never know. Okay, but if you practice more and more questions, you will be familiar with different methods, and once you read the question, the first method that is coming to your mind, that's the way we always try problems. Read the question, think, we will have a method in our mind. We're going to try that method. That may not be the fastest, but if you try more and more problems, the method that is coming to your mind will be the fastest, or at least one among the fastest, at least, if not the fastest, one among the fastest method. So that's the idea. Practice more problems. Okay, you have to practice not just number of problems. You have to understand different types of problems and practice all of them. Then the method that is coming to your mind while reading the question will be the fastest, or will be one of the fastest methods, if not the fastest. So that's how you crack it. All right. So yes, that's what I expected. The velocity time graph of a body traveling along a straight line is given below. The distance traveled and displacement of the body are respectively. Okay, we have a graph. We have a graph, velocity time graph of a body traveling along a straight line. The distance traveled and the displacement of the body are respectively. We have a velocity time graph. This is a velocity time graph. Okay. What we need is displacement and distance and displacement. So from velocity time graph, how do you find out distance and displacement? How do you find out distance and displacement? Displacement is the area of VT graph. Displacement is the area of VT graph. Displacement is the area under VT graph. So this is a trapezium. So the area is equal to half h into this side is A and this side is B, A plus B. Okay, so this is equal to half. What is H? 1 into, what is A? What is A? What is A? A is this much. That is, A is equal to 2 and B is equal to 4. 2 plus 4. So this is going to be 1 by 2 into 6. This is 3 meters square. Sorry, 3 meter. Okay. What about this area? It's a triangle half BH. So base is this much and this is the height. So this is half into, half into, what is the base? Base is 4 to 7, that is 3 into height is over here, it's 2. So this is going to be 3. So now be careful. We have found out the area, but the first trapezium part is in the positive side of x-axis. Not x-axis, y-axis. It's on the top, and the next part, the triangle part, is in the negative side. What does that mean? In the first trapezium side, the velocity is positive. It is moving towards the right. And in the next part, it's actually coming in the opposite direction. So what is the distance? And what is the displacement? What is the distance and what is the displacement? So we will be having these kind of live classes in the YouTube channel of Dopa. You can subscribe and listen to more classes like this. Okay. So anyway, what is the distance? What is the displacement? Somebody asked a question. Best reference book for physics for NEET. So I don't recommend any specific books actually. The first thing is NCERT textbook. All right. NCERT textbook and the exercise problems at the end of every chapter. Usually, if you are a CBSE student, if you are a CBSE syllabus student, the +1 chapters will be usually skipped or not usually completed thoroughly because there is no public exam for 11th. So 11 chapters will be a problem for you. So, and for state syllabus students, usually we will cover, I have been a state syllabus student for 11th and 12th. We will be covering all the chapters, but only the points that will be asked for the 12th board exam. So that's not enough for entrance exam. So you have to learn the NCERT textbook thoroughly, including the exercise problems at the back of every chapter. So that's the first book, that is your textbook, that is your syllabus. Then if you want, you can refer other books also, such as DC Pandey, Arihant Publications, DC Pandey or HC Verma. But I don't recommend any of those things. I don't, DC Pandey is alright. I don't recommend HC Verma because it's, too much higher for NEET syllabus. Even the last NEET exam, this 2020 NEET exam was really simple. No one has to study even the complete NCERT to solve all the problems. Okay, so DC Pandey books are good, and we have a lot of questions. There is a pool of questions that is available in Dopa application for you. So you can work out problems from the app of Dopa, from the pool of questions. So the only thing is understand the concept first, then work out problems. Okay, work out a lot of problems, variety of problems. So there are a few publications. There are a few publications like Zengage or MTG, NEET Champion. All those things are usually referred by students. The first thing is complete NCERT. Then you can move on to other materials. All right. So distance is 6 meters, and what is the displacement? What is the displacement? It moves 3 meters towards the right and it moves 3 meters towards the left in the next part. So the displacement is 0. So here you can take this as -2. Then you will get -3 meters. So what you get from the area is the displacement. So in the first part we got 3 meter as positive, means the positive displacement. In the second part we have the velocity as negative, so that's a negative displacement, means it's coming back. Of course, solving numerical problems is applicable for board exam. Of course, it's going to help you in the board exam. You know, studying for entrance does not hold you back in the board exam. That's for sure. But only studying for board exam will not get you anywhere during entrance. So entrance is the whole thing, everything. So once you know everything related to entrance exams, or if you're practicing problems for entrance exam, then board exam questions are going to be really easy. But you need to know the syllabus thoroughly and concepts thoroughly. Some of the derivations also that will be asked in the board exams. That's why. Okay, so the displacement is 0 and the distance is 6 meters. So let's see the options. Yes, right, first option, 6 meters and 0, because in the question first it's asked distance then displacement. First distance then displacement. Okay, don't do the other way, there is no other option. Okay, then it's fine. So let's move on to the next one. Again, a question from a graph. Okay, figure shows the velocity time graph of a particle. Its average velocity in 20 seconds will be. Simple. It's a velocity time graph, average velocity in 20 seconds. What is average velocity? Average velocity is total displacement divided by total time. It's total displacement divided by total time. So what is the total displacement? Total displacement is the area of VT graph divided by total time. It's 20 seconds. Okay, as simple as that. So what is the area of this graph? This is equal to, again it's a trapezium, so it's half h into a plus b, half height into sum of parallel sides, sum of the length of parallel sides. So half into the height is going to be, this is 5. All right, this is 5 into this length is 10 and over the total is 20. So 10 plus 20 whole divided by 20. So this is going to be 5 into 30 divided by 2 into 20. So zeros gets cancelled. It's 15 by 4. What is 15 by 4? What is 15 by 4? It's 3.75. The unit is meter per second. Why you used 60 in the equation? Which equation? Which equation are you talking about? 60. Which 60 are you talking about? Shahana, why you used 60 in the equation? Which 60 are you talking about? I don't see any 60s in my equations. So the question is, what is the average velocity in 20 seconds? So the right answer here is 3.75 meter per second. Is that clear? Did I make any mistakes? No, so right answer is over here. It's 3.75 meter per second. Okay. Yes. So let's move on. Move on to the next question. A particle passes through a point A and B, which are 90 meters apart. It takes 6 seconds to cover this distance with uniform acceleration. Velocity of particle when it passes through point B is 20 meters per second. What is the initial velocity of point A? So simple. Again, read the question once again and solve it yourself. Let's see. particle passes through a point A and B which are 90 meter apart. It takes 6 seconds to cover this distance with uniform acceleration. So a particle is moving with a uniform acceleration. It passes through 2 points A and B. Okay, passes through 2 points. So the total time is 6 seconds between 6 seconds between those 2 points A and B. All right. So which are 90 meter apart. 90 meter apart. The velocity of the particle when it passes through point B is 20 meter per second. So the velocity is keep on increasing. So the velocity over here is 20 meter per second. It has an acceleration. The same acceleration is there throughout the motion. The same acceleration is there. It's keep on accelerating. All right. The velocity is not a constant at all. Okay. So the question is, what is the initial velocity at point A? So what must have been its initial velocity over here? What must have been u? So what are the things that we have? Things that we have, the informations that those are given, we need to find out the initial velocity. We have the final velocity which is 20 meter per second. We have the displacement which is 90 meters and we have the time which is 6 seconds. What is the equation that is connecting all these four? What is the equation that is connecting all these four quantities? Honestly, there is no equation connecting all the four quantities. Because look at each of the equation. V equal to u plus at. We have initial velocity, final velocity, acceleration and time. There is no displacement. We don't know the acceleration also. Out of the 5 quantities, we don't know we don't know initial velocity, we don't know acceleration. All right. So each of the equation S equal to ut plus half at square has displacement, initial velocity, time and acceleration. No final velocity. No final velocity. V square equal to u square plus 2as. We have final velocity, initial velocity, acceleration and displacement. No time. No time. So each of the 3 equations of motions has 4 variables in it. Okay, we need, we have 3 given variables and we need to find out the initial velocity. So my idea is we have to use 2 equations from these 3. Out of these 3, we have to use 2 equations. How is that? Let me tell you. We have the time, right? So the acceleration is equal to v minus u by t. Okay. So acceleration into time is equal to v minus u. Okay. So we don't know the acceleration. What is the time? What is the time? Time is 6. So this is 6a is equal to v is 20 minus u. We have that condition. All right. So a is equal to 20 minus u by 6. Use this equation in v square equal to u square plus 2as. So v square is 20 square is equal to u square. We want to find out u. We don't know u. Plus 2 into what is acceleration? 20 minus u by 6 into displacement, it's 90. So in that expression, the only variable is u. So let's find out. 400 is equal to u square plus 6 and 90 cancelled. So 15, 2 into 15 is 30 into 20 minus u. So 400 is equal to u square plus 600 minus 30u. Take everything on to the right side. 0 is equal to u square minus 30u plus 200. Okay. So let's solve that quadratic equation. U square minus 30u plus 200 is equal to 0. So this can be resolved into 2 parts. u minus 10 into u minus 20 equal to 0. U minus 10 into u minus 20 equal to 0. Alright. So, here we have two answers. U is either equal to 10 or u equal to 20. So, which one are we going to take? Which one are we going to take? Which one are we going to take? Yes? We have two answers for you. Which one is the right answer? So, read the question again. Particle passes through a point A and B, which are 90 meters apart. It takes 6 seconds to cover this distance with uniform acceleration. Velocity of particle when it passes through B point is 20 meters per second. What is its initial velocity? It is accelerating. It has a velocity of 20 meters per second over here. Then the initial velocity must be less than that, right? So, since we have two answers, which one is the right one? Which one is the right one? The right one is u is equal to 10 meters per second. U is equal to 10 because u cannot be 20 because it's accelerating. Alright. So, that's our right answer, option A. So, as mentioned in the chat, there are a lot of practice problems available in Dopa app. Okay. So, you can download that and start doing more problems. So, learn the NCERT textbook and work out a lot of problems. Okay. So, and also you can get classes in the app also. Moving on to the next one. Two balls X and Y are thrown from top of tower, one vertically upward, the other vertically downward with same speed. If time taken by them to reach the ground is 6 seconds and 2 seconds respectively, then the height of the tower and the initial speed of each ball are. So, yes. Next question, two balls X and Y are thrown from top of tower, one vertically upward and the other vertically downwards with the same speed. If time taken by them to reach the ground is 6 seconds and 2 seconds respectively. Obviously, the one that is thrown upwards is going to take 6 seconds to come back and reach the ground, and the one that is thrown downwards is going to take 2 seconds. That's obvious, because the one thrown downwards has to reach the ground first. Thrown upward has to go up and come back. So, it's going to take more time. Then height of the tower and the initial speed of each ball are. Okay. So, it's a typical question from motion in a straight line. We have, let's say we have a tower of height h. We throw a ball down with some initial velocity, which is u, and throw another ball up, the same speed u. The ball thrown down reaches the ground in 2 seconds. The thrown up goes up and comes back and reaches the ground in 6 seconds. Okay. So, what we need is u and h. All right. So, let's take directions. Let's take positive, upwards as positive and downwards as negative. Let's take upwards as positive and downwards as negative. So, consider the first one. This is the first and this is the second. Consider the first one. Initial velocity is minus u. Initial velocity is minus u. The displacement, let's write it like this, u is equal to minus u. Time taken is 2 seconds. The displacement is minus h. And the acceleration, it's all because of acceleration due to gravity, which is g given as 10 meters per second square. So, the acceleration over here is minus 10. So, let's write an equation from here. We have initial velocity, displacement, acceleration and time. So, s equal to ut plus half at square. Okay. So what is s? S is minus h is equal to minus u into 2 plus half into minus 10 into 2 square. Okay. So minus h is equal to minus 2u. This is 2 square. It's minus 20. All right. So let's multiply everything with a negative. H is equal to 2u plus 20. Let's keep that equation. That is an equation connecting u and h, initial velocity and the height of the tower. For the second one, the initial velocity is plus u because it's going up. The displacement or the time taken is 6 seconds, and the displacement is again, the object has gone up and came back to the ground, right? So the displacement is the change in position, final minus initial. Finally, it is at h meters down, means the displacement is minus h. The acceleration is nothing but it's minus 10 meters per second square. So displacement that is acting on the object is also g. So use the same equation, s equal to ut plus half at square. Minus h is equal to u into 6 plus half a into half minus 10 into 6 square. So minus h is equal to 6u. It's minus 5 into 36, minus 5 into 36. So minus h is equal to 6u minus 5 into 36 is 180, minus 180. So that's our second equation. So we are going to solve these two. So we have two equations. H is equal to 2u plus 20 and minus h is equal to 6u minus 180. Add these two. 0 is equal to 8u minus 160. That means 8u is equal to 160. U is equal to 160 by 8, which is 20 meter per second. The velocity with which we have thrown the balls is 20 downwards and 20 upwards. So now what is h? H is equal to 2u plus 20. So this is 2 into u is 20 plus 20. So this is going to be 40 plus 20, 60 meter. So the tower, the height of the tower, zoom in or zoom out. You want to see the whole thing? So that's how it is. Okay. So the height of the tower is 60 meters and the initial velocities are 20 meter per second. Okay. Raswa, this is what you wanted. Zoom out and put everything in one frame. So clear the answer? Yes, u is equal to 20 meter per second, right? So go back to the options. Yes, sure. Read the question again. Two balls x and y are thrown from top of tower, one vertically upward and the other vertically downward with the same speed. Both of them has the same initial speed. If time taken by them to reach the ground is 6 seconds, the going up one will take 6 seconds and the going down will take 2 seconds. Okay. Then the height of the tower and the initial speed of each ball are. So we have the answer, height is 60 meter and the initial speed is 20 meter per second. The right answer is the third one. So yeah, here it is. This is your answer. All right. So let's move on. Move on to the next question. Two trains of length 100 meter and other of length 125 meter are moving mutually opposite directions along parallel lines. Meet each other, each with speed 10 meter per second. If their acceleration is 0.3 meter per second square and 0.2 meter per second square respectively, then the time they take to pass each other will be. So once again, two trains, one of length 100 meter and other of length 125 meter are moving in mutually opposite directions along parallel lines, meet each other, each with 10 meter per second. So both the trains are moving in opposite parallel lines. They pass each other. So when they are close, or when they are meeting, both of them has 10 meter per second velocity. Both of them are accelerating. The accelerations are 0.3 meter per second square and 0.2 meter per second square respectively. Then the time they take to pass each other will be. Okay. So let's see. I'm going to draw a train like this. This is one of the trains. Two trains. Let's take this as train number 1, which has 100 meter length, and another of train length 125 meter. It's coming in the opposite direction. It is much longer. It's 125 meter. This is B. Okay. Each with speed. Their speeds are 10 meter per second each. 10 meter per second, and in this direction also 10 meter per second. Okay. If their acceleration are 0.3 meter per second square and 0.2 meter per second square, both of them has an acceleration 0.3 meter per second square and it's more accelerating in this direction. This is accelerating in this direction, 0.2 meter per second square. Okay. Respectively, then the time they take to pass each other. Pass each other means completely cross each other. Okay. So this thing can be done using relative motion. I hope this is going to be, this will be taking much lesser time than the, the question that we did in relative and took a lot of time. So what's mean by, crossing each other, take to pass each other means this train has to move over here. Do you get that? Okay. Completely pass means the tail of the first train has to cover the tail of the second train. Okay. So at a later time, this one has to reach over here. That's the idea. Okay. So what is the displacement? It's not just that first train is moving. Both the trains are moving. Both the trains are moving, but we are considering everything with respect to the second train, with respect to B. With respect to B. Alright. So with respect to B, let's say this is B. Okay. And the train A is moving with respect to B. B is stationary. Assumed like that. So B, this is the length of A. That means it's starting to cross the train over here. Okay. Now it has to the tail end of the first train has to cover the tail end of the second train. Okay. So how much is the displacement of A with respect to B? Displacement of A with respect to B. If B is assumed to be stationary, how much distance A has covered? Take the front end. Take the front end. The front end has moved a distance of, look at that. The front end has moved that much distance. That, how much is that? Or you can consider the tail end also. If you take the tail end has moved this much. Okay. How much is the displacement? That is going to be the total length of the trains. Okay. The total length of the trains. Okay, so displacement of A with respect to B is going to be 100 plus 125, that is 225 meters. Similarly, what is the velocity of A with respect to B? Velocity of A with respect to B. Velocity of A with respect to B, since both of them are in the opposite direction, it's 10 minus minus 10, that is 20 meter per second. What is the acceleration of A with respect to B? It's acceleration of A minus acceleration of B. Now look at that. What is the acceleration of A? This is the acceleration of A, that is 0.3. And what is the acceleration of B? It's 0.2. So this is 0.3 minus 0.2 because it's in the opposite direction. Okay, so this is equal to 0.5 meter per second square. So we have the displacement. Look at that, displacement, velocity, acceleration. What we need is time. So how are we going to find out the time? How are we going to find out the time? Which equation are we using? S equal to ut plus half a t square. All right, S equal to ut plus half a t square. So the displacement is 225. Initial velocity is 20 into t. Acceleration is half into 0.5 t square. So this is 225 is equal to 20t plus 0.5 is actually 1 by 2. This is t square by 4. Okay, so that's the quadratic equation that we want to solve. So multiply everything with 4. This is 900 is equal to 80t plus t square. T square minus 80t, sorry, plus 80t minus 900 is equal to 0. Factorize them. T plus 90 into t minus 10 is equal to 0. 90 into minus 10 is minus 900. 90 plus minus 10 is 80. So we have two answers. T is equal to minus 90 or t is equal to 10. So which one is our answer? Which one is going to be our answer? Which one is going to be our answer? We have two answers for time. One is minus 90 and the other one is 10. So definitely it's going to be 10. Okay. So the right answer here is 10 seconds. Okay. So we have been discussing problems for almost 1.5 hours, more than 1.5 hours now. So we cannot continue like this. Some of the problems that we have discussed are much tougher than the questions that asked in the last NEET exam or any NEET exams. Okay. So in my opinion, you have to work out problems which are just above the level of NEET exam. Then only you can comfortably work out problems that is coming for the exam. Okay. All the time, whichever entrance exam that you are preparing for, you have to be comfortable solving problem. You have to practice solving problems which are at a level just above the question level of every exam. Then only you will be able to solve the questions in the exam comfortably. All right. So we have more questions to work out. We'll be having these kind of live sessions, problem solving sessions, and you can subscribe to the channel and download the application to get the notification. Okay, so that's all. If you have any doubts, you can ask me now. Otherwise, we are going to wind up the session. Okay, I'll wait for a minute to wind up. If you have any doubts or questions or suggestions, you can give me the feedback now. Okay, through the chat. Thank you. You're welcome, Ashna. So that's all. Thank you all. Thank you for listening. See you.